Hello viewers, in today's session we are going to discuss another important problem from differentiability of functions, and in this session we are going to prove that the function f of x, which is equal to a mod of 10x, is not differentiable at x is equal to 0, right? So to prove that this function is non-differentiable at x is equal to 0, we have to first calculate the value of left hand derivative and the right hand derivative, and then we can draw the conclusion that this function is not differentiable at x is equal to 0. So let us start. So now the definition of right hand derivative can be written in this form, that is limit h tends to 0 f of a plus h, and here we have minus f of a divided by h. So the right hand derivative is defined by this limit, and here the point a is 0, right? So a is equal to 0. So now the right hand derivative of this function can be written as limit h tends to 0. Now here we have f of a plus h, a is 0. So we have 0 plus h minus f of 0, and here we have h. So now we have limit h tends to 0, f of h minus f of 0 divided by h. Now f of h can be written easily with the help of this function by replacing x by h. So we have limit h tends to 0, and we have mod of tan h, and here we have f of 0. Now f of 0 can be calculated by this function, so we have mod of tan 0, and tan 0 is 0, so mod of 0 is 0. So here we have 0 and here we have h. So now we have limit h tends to 0, and here we have mod of tan h divided by h. So now we can write the value of mod of tan h is equal to tan h, because this quantity h is infinitesimally very small, and it is a positive quantity, so that tangent of h, it always lies in the first quadrant, and tangent of x in the first quadrant is always positive, right? So tan of h is greater than 0. So we can now write mod of tan h is equal to tan h. So now the limit h tends to 0, tan h over h is equal to 1, because from the standard results on limits, we know that limit theta tends to 0, tan theta over theta is equal to 1, right? So the value of this limit is equal to 1. So the value of right hand derivative of f of x is equal to mod 10x at x is equal to 0 or a is equal to 0 is 1. So the right hand derivative has the value plus 1 at x is equal to 0. So now let us find out the value of left hand derivative. So now the left hand derivative is defined by this limit. Limit h tends to 0. We have f of a minus h minus f of a divided by minus h. And here we have the notation for left hand derivative. So we have f prime of a. So now the value of a is 0. So we can now write a limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. Now we have limit h tends to 0, f of minus h minus f of 0 is 0. So here we have minus h. So we have limit h tends to 0, f of minus h can be obtained by replacing x by minus h. So we have mod of tan of minus h, and here we have in the denominator minus h. So now we can write limit h tends to 0, and from trigonometry we know that tangent of minus theta is equal to negative of tangent of theta. So here we have mod of minus tan h, and here we have minus h. So now we can write the value of mod of minus tan h is equal to simply tan h by properties of a mod function, right? Because a mod of minus p is equal to p, right? Okay. So now here we can now write limit h tends to 0, and we have here simply a tan h, and in the denominator we have minus h. So we can take this negative sign in front of the limit notation, and we have limit h tends to 0 tan h over h. Now using this result, that is a limit theta tends to 0, tan theta over theta is equal to 1. So the value of this limit is equal to 1. So we have the left hand derivative as minus 1. So the left hand derivative is equal to negative 1 at x is equal to 0. So now from this discussion, we can easily conclude that although the right hand derivative and the left hand derivative both exist and they are finite, but they are not equal to each other. That is, a right hand derivative is not equal to the left hand derivative at x is equal to 0, because plus 1 is not equal to minus 1, right? And this suggests that this function is not differentiable at x is equal to 0, because the condition for differentiability of a function is that the right hand derivative and the left hand derivative both exist. They should be finite, and in addition to this, the derivatives should be equal to each other, right? But in this case, the two derivatives, that is the right hand derivative and the left hand derivative, are not equal to each other. Hence we can claim that this function is not differentiable at x is equal to 0, right? And similarly we can prove that this function is not differentiable at x is equal to pi, and similarly x is equal to 2 pi, and so on. And in general we can say that f of x is equal to mod tan x is not differentiable at this point, that is x is equal to n pi, where n belongs to the set of integers.